Problem.
Okay.
Okay, line up.
Okay, we're live. Welcome everyone to the first workshop for the 2024 ETH Toronto and ETH Women Hackathon. I'm James from DoraHacks, and I'm delighted to be joined by some of the team members from ICPHub Canada and US, who are a sponsor of the hackathon, who will be giving us a presentation today regarding their bounty and some other information about ICP. So just a quick intro from me. My name's James, and DoraHacks, we are the largest multi-chain hackathon organizer and developer incentive platform. We've been supporting hackathons for about 10 years now, but this is a really exciting one that we've supported a couple of times in the past, and it's live now. So the 2024 ETH Toronto and ETH Women Hackathon, the online submissions and registration is currently live. There's just under a month left of that, and the event itself is taking place in August. So whether you're going in person or you want to take part online virtually, it's available to everyone. So make sure you get involved. We'll be putting links in the comments below. So check them out to head over to the hackathon page on DoraHacks. Great. So again, I'm delighted to be joined by Anjali and Chetan from ICPHub. Guys, if you want to give us a quick introduction to yourselves and ICPHub, and then I'll hand over to you for the presentation.
Wonderful. Thank you, James. Hello, everybody. I am Anjali. I am the Developer Relations Manager at ICPHub Canada and US. And today we are holding a workshop explaining the canister management in the Internet Computer Protocol. This workshop is actually a part of the ETH Toronto and ETH Women Hackathon workshops. So we are organizing such workshops to help the participants and everyone learn more about the Internet Computer Protocol, its features, and get going to build awesome projects and dApps on this platform. So yeah, I'm supported by my colleague here, Chetan.
Yeah, hi guys. Hi, this is Chetan, Developer Relations at ICPHub Canada and US. And yeah, Anjali has already shared the objective of this live stream. This is a workshop for helping you guys started with ICP. The topic will be today ICP Canister Management, and we'll be sharing about ICP technology. I guess everyone must have already started with their projects, and all, as James said, that the registrations are already live. Meanwhile, if you guys have any doubts, the comment section is always open. You can reach out to us in person as well. You have our Discord handles on. You can anytime text us on Discord. So yeah, let's start. And if you guys have any doubts, just keep typing in the chat box. We are already monitoring it. And yeah, let's go. And we are looking forward to some amazing projects. Yeah, I guess we can start.
Yeah, wonderful. Thank you so much, Chetan. So I think before starting and talking about the canister management today, I would first like to discuss a little bit about the bounties at the hackathon. Can we move to the next slide? Yeah. So we are ICP is having two bounties for this ETH Toronto and ETH Women separately. And so the description of the bounty is that you have to basically, the participants have to build some project which enables or utilizes the cross-chain capabilities of the ICP protocol. I know it may sound a little more technical if you are a beginner right now, but then once you attend these workshops and you understand more about the canister management, the ICP protocol, I'm sure that this would be a very easy challenge for you. So we basically want you to deploy a project on the ICP mainnet, not the testnet specifically. And the basic requirement would be to build a backend canister smart contract, and the objective of it would have to be something related to cross-chain capabilities, maybe some threshold, the threshold keys, or maybe, so ICP has this beautiful technology wherein it can integrate with blockchains like Bitcoin and Ethereum in the native sense with its own native tokens. So we want you to implement that functionality into a project. And of course, there are wonderful prizes for it. We have $1,000 each prizes for each Toronto and Women. And all the best for these bounties. So in case you want more explanation on these bounties or have any doubts and queries, please, you could type your queries in the chat box, or probably you could reach out to us on the Discord community channel as well. So now let's get started with today's workshop. So before we go into what ICP exactly is, and before we understand what is canisters, let's first talk about Web 3.0. What exactly is Web 3.0? For some people who are new to this field, so I would like to, brief you about this in a very simple way that uh, we have three transitions in the internet. We have one. We started off with Web 1.0. This was like when we just started with the internet. There were static websites, for example, Wikipedia like websites, where you could go and read the data. That kind of internet was known as the read internet, because you could take information from the internet, but you could not provide any feedback, or you could not interact with the internet in any ways. That was actually supplemented, or that was carried forward by Web 2.0. Now, Web 2.0 was the Facebook and the Orkut and the all these social media platforms or the e-commerce websites, where you are also giving your inputs to the internet. That internet is known as the read and the write internet, and that is Web 2.0 for us. Now, as we all know that the Web 2 took internet by storm, and there were a lot of users onboarded through Web 2 on the internet. There were so many social media identities created, and data became the new oil for us. And there were some big tech giants like Facebook, Amazon, and Google who took this benefit of all this and created it into business and owned our data, and they're utilizing it still. And that is where Web 3.0 comes into picture. Web 3.0 stands for reading, writing, and owning the internet. You own your own data. Nobody else is the owner of your data. And how does Web 3.0 achieves this? It achieves this by decentralization. We completely decentralize the data, and the underlying technology behind it is known as the blockchain technology. So blockchain technology is the enabler for Web 3.0, wherein we decentralize the system so that there is no one single party which could claim the data. And that is a revolutionary step in, I think, in the internet world, because then that would mean that we own our own data and there is no single person holding it. So that is what Web 3.0 whole essence is. So as I told you, Web 3.0 has we can move to the next slide. So Web 3.0 is backed by blockchain technologies. So we had Bitcoin coming as the first blockchain, and then it's followed by Ethereum and many other blockchains. So there are a lot of blockchains, famous blockchains, which have their own unique features and landscapes. But still, most of the blockchains are facing, the users of these blockchains are facing some common problems. So, for example, there are scalability issues. There is high transaction fees for most of these blockchains, where if you have interacted and if you gone through the dApps of the Ethereum blockchain, you would realize that there is huge transaction fees, which is called as the gas fees. And also the transaction speeds are super slow. And these are some of the major problems which we are facing these days. Next slide, please. So that is what Internet Computer Protocol is here to solve. So I think we could say that the third great innovation in blockchain is the infinite blockchain, which is the ICP. So in 2009, Bitcoin was invented, and Bitcoin is largely the first blockchain to be created. And it is mostly about cryptocurrency. So what Bitcoin gave us was cryptocurrency, the digital way of making payments, where you need not know where you have no boundaries. It's global. So it was a revolution. It's still a revolutionary blockchain, and it was followed by 2015 smart contracts, which was introduced to us by the Ethereum blockchain. So through Ethereum, we understood that we could also create some code where we could host, we could build websites which have the blockchain at the back end, and there is something known as smart contracts. So smart contracts are basically self-executing codes, wherein the code is not governed by a few people, but it is run automated. And now that had huge power, and that was completely an innovation in blockchain, and it took it by storm. And now in 2021, Internet Computer Protocol came into existence, which is called the third great innovation. So now ICP has brought something new to the table. So we already have some two major inventions, but what ICP does is enhance the capabilities of the existing blockchains. Next slide, please. So, yeah. So, what are the major features of Internet Computer Protocol? Internet Computer Protocol has unlimited scalability. It has exceptionally high speed and drastically low costs. I know these may sound, without data, these facts may sound a little, not believable, but trust me, when I'll share the data with you, Internet Computer Protocol is the fastest and the most scalable blockchain in existence today. Can we move to the next slide? So here is the data-backed research for this. If you could see, so I have put in a lot of metrics. And if you could see on the left side, we have some major blockchains: ICP, Avalanche, Cardano, Ethereum, Solana, all the famous ones. And on the right-hand side, we have some data, some calculations, basically, on the basic metrics, wherein you could compare all these blockchains. If you could see, for example, on the average TPS, which is the average transactions per second, we could see that for Solana, it's almost 700. For Ethereum, it's 12. I mean, in 1 second, an Ethereum blockchain is able to process 12 transactions. But if you can compare it with the ICP blockchain, it could complete 3,200 transactions in that 1 second. Also, I would like to highlight on the average, on the on-chain storage cost, the last metric. I think that's also a very important metric, which would help you get perspective of the potential behind the ICP blockchain. So we know that storing data on blockchain has always been expensive, and we know that. For example, if you could see the data, if you want to store 1 GB of data fully on chain, then it would take almost $35,000 for a user to store that data on a Solana blockchain. And you could see the number reaches in millions for Ethereum blockchain. Since Ethereum blockchain is facing this issue of, this high transaction fees, so you could have to spend almost this much amount to store if you want to store 1 GB of data. Perhaps that is the reason why most of the applications built, most of the blockchains, they are not 100% fully on chain. Only the relevant and the important transactional data is stored on blockchain, and rest everything is stored off chain. But in case of ICP, if you want to store 1 GB of data completely on the blockchain, it would just cost you $5. I think this would give you enough perspective on the amazing potential of this technology and of this blockchain. So today we are going to discuss more about the ICP blockchain. The Internet Computer Protocol came into existence in 2021 and has taken the internet by storm by its amazing potential to create decentralized applications which are huge, infinitely scalable, and very, very convenient for the end users. Next slide, please. So my colleague Chetan will now tell you about the important features of the Internet Computer Protocol. Over to you, Chetan.
Yeah, thanks, Anjali. Thanks for explaining everything about ICP. I guess everyone must be having at least an overview. Definitely, ICP is a large, immense technology which has a lot number of features, but we can't really cover it in a very short span of time. But anyways, thanks, Anjali, for introducing us to all the key functionalities that are quite everyone has been taking their applications on ICP blockchain, and this definitely is a major milestone that we are achieving, that we are having the latest good number of projects, be it in the DAI, be it any categories, be it in DAOs, be it NFTs. All these projects have been growing crazily. Now I would like to just enhance more I would like to add more of the features that are present on ICP. First of all, there's the canister architecture. Canister architecture is the key response. Just a second. Yeah, so sorry. So the canister architecture is our main key fundamental feature that helps us differentiate us from other blockchains. I'll definitely take a look upon that as well on the next slide. But let us just give a look up a small that we are transferring our complete data on chain. Now, many blockchains, be it layer one, side chains, everyone claims that we are the blockchains that takes the data completely on chain. Completely on chain means every single component, be it your images, be it anything like that, everything is being stored on chain 100% only on ICP. And you would be amazed that if you will be seeing the cost of storing the data on chain in other blockchains, be it in the Ethereum or the so-called layer 1 blockchains, the cost of storing that on cost of storing the data on these blockchains is pretty much high, which is not even accessible to many users. So that is the reason ICP came into play. And if I just shock you with the numbers, it's the actual amount goes into millions. And in ICP, we are just talking about $5 per GB per year. So you can just imagine how drastic the difference is. Apart from that, there's the reverse gas model. So reverse gas model is again a key functionality only for ICP, which will be taking which for understanding that we will have take a deep dive into canister architecture. So we'll be going that into next slide itself. And also the interoperability with the chains. I guess everyone, if you are on ICP, you must have uh, okay. Yeah. If you're on I if you're on blockchains, just a second. Okay, so if you so ICP blockchain is the only blockchain, not only blockchain, many blockchains do it, but the thing is that if you are on ICP blockchain, you must have heard the concept of chain key cryptography. What chain key cryptography is? It is based upon the reverse gas fees model itself. So right now, ICP blockchain is interoperable with Bitcoin, BTC blockchain, and Ethereum. CKBTC is the technology which states chain key BTC, and again similarly CK ETH, which is chain key ETH. Hopefully, we are doing the CK Soul as well in the future. But anyways, CK BTC and CK ETH are going pretty much fine right now. This interoperability bit has helped us do the BTC transaction on ICP very smoothly. But now let's take upon the key canister architecture, which is the main fundamental layer helping us do these operations, help taking the data completely on chain, and all that interoperability seamlessly. Now, this architecture, what exactly are canisters? So, canister architecture is basically, let's say you are writing some backend code. Canisters, so these backend code in Web3 blockchain, you must have heard the term of smart contracts. What are smart contracts? These are just piece of code, and which these are piece of code that not just stores the code but also the state of the blockchain. What exactly the state of the data is getting stored on the blockchain. Right now, on ICP blockchain, we just call these smart contracts as canisters. Nothing much difference. If you are from the Web3 space itself, you must be knowing the concept of smart contracts. It is just a bundle of code that is put on the chain, and you can perform the transactions, or let's say you can perform any operations on these canisters, sorry, these smart contracts in other blockchain. And these similar smart contracts in ICP blockchain are terminology is given as canisters. So these are the building blocks of ICP, and these hold the main layer of the ICP architecture. These smart contracts can store both code and state of the blockchain. Apart from that, what is the key differentiator here from other blockchains? These canisters are meant to be automatically scalable, and the performance automatically scales once the transactions per blockchain per block is increasing. Let's say this blockchain was designed so that the transactions and the network never goes down. I guess if everyone has heard of Sol, right? But Sol also, we have seen the downtime has been pretty much increasing because of the transactions are getting so heavily stuffed there. But ICP, by the technology it has, we haven't seen these many downtimes, obviously. But this is because the auto scalability and also the performance that the reverse gas fees model has given us. Yeah, so this was all about the building blocks of ICP, the canister terminology. Now, I would just try to give a look upon that what exactly is the life cycle of a canister. So these are the four steps when you install a canister. when you try to program something on ICP blockchain, these are the four stages that come in the life cycle of a canister. First of all, you definitely create the canister. Then I'll just take a deep dive into the. Let me share my screen again. 1 second. Perfect. So here's the documentation, the developer documentation. I guess for every developer, one thing that ICP has given, for me also personally, that developer documentation has been quite helpful whenever I am stuck in some problem or I am reading about the ICP technology. So you have to just move on to this page, which is canister lifecycle. So canister lifecycle comes on with the first step is creating a canister. Let's say I am a developer, or personally you are a developer of each Toronto hackathon. You just create a canister, you get a access of canister ID. Basically, the canister, which is the building block, you are the controller of that canister. You create this canister via the help of dfx command line. I will tell you what dfx is. It is just another tool to help you getting start with building with ICP. So basically, as a developer, you need to have DFX installed in your ICP blockchain if you want to program on ICP blockchain. You create the canister, you get the canister ID from the canister code that you are creating. That canister ID is unique to your own canister, which is basically your code. You are the controller of that code. Now, in the next step, these canisters are something, there's a term called as WASM, which is WebAssembly modules. So WebAssembly modules is the technology which we are using here, which the Definity team has been integrating into ICP. These all DFX command line and all DFX canister are installed via WASM libraries, which is the WebAssembly modules. These codes are installed by the controller on the DFX block on the ICP blockchain using the WebAssembly modules. Now, once these modules help us transfer the code, which is basically help us transfer the canisters on chain, these will be further called by the user. Let's say the function is to get some data, get some API. Let's say in Web2 world, if you were programming this complete if these operations were being called, you would have just gotten, you would have fetched your data from some API. In the similar manner, this data which is installed on the blockchain, as a user you can call. Basically, let's say you perform some operations on the website. You would be amazed that right now also the ICP blockchain is also, this ICP website is also on the internet identity on ICP blockchain itself. So whenever you are clicking some button, it everything is being fetched from ICP blockchain itself. So, and that too very seamlessly, right? So this is the, as a user you can just call upon these functions, and afterwards, let's say you want to all the operations, like you can stop, you can start, you, let's say you want to change some deployment cycles needs to be changed, or you want to change the settings, you want to delete something. These all are managed by the controller. A controller, let's say internet computer, this ICP website is managed by DFX team. Anyone who has the access, basically this website will be giving us a canister ID. This canister ID will be controlled, will be managed by the controller, which is DFX team. And they will be completely like they, as in the Web2 term also, right? As a controller you can have the complete access. These are upgradable smart contracts. You can time to time change it as per the requirements, right? Now coming to the, now what exactly, now I'll just, so this is basically the canister architecture. If you want to read more about it, that how the we were talking about the term called as auto scaling, how this auto scaling feature works. Basically this comes with the code base example, which I guess you should not be worried about right now because you are just making your project for the hackathon. But in future, if you want to go take your hackathon project to a grant level project, grants will be talking at the end of the session. So let's say you're continuing your project to the grant level project where you're building your MVP and launching it for the users. Auto scaling is the feature that you need to be well versed about, because at the end, the storing, the data storage and everything needs to be done very constructively, so that you are not wasting your, as basically you are not wasting your ICP energy, which is the fuel of the canister, right? But yeah, let's skip it to right now. As of now, our goal is to build our project as fast as possible on the in the ETH Toronto hackathon. Now, I would just give you, I guess everything is clear right now. Now, before moving ahead, I just want to have a quick thumbs up in the chat box that is everything going fine? Everything going fine at user, like everyone is understanding here? Any doubts till now? Thanks, Anjali. Thanks for sharing all these, all handling all the doubts meanwhile. So yeah, I guess languages, the native language for ICP has already been covered by Anjali. That there are other languages also which are supported by ICP ecosystem, which is Python, which is Rust, which is TypeScript. But yeah, we just want to rely upon Motoko because this is the language which has given us the power to basically scale the ICP blockchain to the potential that we are on right now. Now, before moving ahead, before Anjali will be giving you the hands-on session, which is basically maintaining this life cycle, how this life cycle is been maintained, I would just give you everyone a quick overview that how you can get this DFX installed in your systems. So if you are a Windows user, a bit problem for you. I would not say problem, but yeah, there's just an additional step in comparison to the Mac user. Let's say you go to developer docs, you click on Motoko, and when you come on the developer environment, these links are getting shared in the chat box anyways. So you come to this developer environment setup, and here you will be getting a link to install DFX. One second. Yep. Yeah, so this is, here's the link. You just go on this link. This link is shared in the chat box. You just go on this link. If you are a Mac user, you go and type it in your terminal. Straight away type it in the terminal. Definitely you need to go for sudo command before, if you don't have permissions, and also the Rosetta, which is the requirement for installing this. If someone is a new user, if someone is from the previous workshop as well, then you can skip this part. This will take just 2 minutes. Sorry for taking you, sorry for equipping your time. So we are just doing it for the new users as well. So if you are a new first time beginner on ICP, this command, this is the requirement. So everyone is asking that DFX, is it a requirement? Yeah. If you have to build upon ICP, you have to do it. It's nothing related that if you have a Git installed in your window, it's not related to that. If you want to get started with ICP, you need to have this handy in your systems. Once you are done with the installation, you just need to check the DFX command, DFX version. DFX, mine is GFX 20. It should be running fine on your system as well. But hold on, if you are a Windows user, you just need to have this WSL. Damn, this WSL is so hectic. I used to do Windows and I know that how this problem was, but I guess some Windows users might even like it because of the Ubuntu. Yeah, Ubuntu has everyone's favorite. But anyways, so WSL install is the thing that you need to have it before running this GFX command. Once the Ubuntu installation is done, you can get this command handy in your systems. And then afterwards, I guess all the Windows user and the Mac users are on the same page as me. And yeah, so let's say you make a new folder here. Yeah, you just go for DFX new. So basically, I would say, what does this new command means? DFX is the command line which you are using here. Then new means you are creating a new project, and then just straight away writing. Okay, now it must be more. Okay, it's quite okay. DFX new and the name of the project. Name of the project being DFX new hello. Okay, you select the backend language. You go for because we are right now focusing only on canisters, and the next topic is canister life cycle. So we are not really focusing on front end part. We just select any of the features out of these two. This project already exists. Damn, I need to change the name. Hello, hello ETH Toronto. Okay, select the backend language. Okay, here's the project created. These were just 2-3 simple steps. You create DFX new hello ETH Toronto or hello anything like that. Yeah, you go into your project. We go for hello ETH Toronto, and then you just go for this in your VS codes. One thing additional you can do is you can have this Motoko thing in your systems, Motoko extension in your system, which helps you visualize the code much better way, right? And then yeah, I'll just give you a quick. I guess everyone is on the same page now. Is everyone on the same page? Any doubts you have till now?
Yeah.
Okay, perfect. Okay, I'll just give a small. Okay, Anjali, would you want to take ahead with the syntax part?
Yeah, Chetan, if you want to say something, you could. I mean, I could maybe
Perfect.
take it
Okay,
from.
so before and Anjali takes you over to the life cycle of canister, I would like to like if you have any doubts, you can ask me. Meanwhile, I would like to just share you that if someone has not done with the syntax part, or let's say you have not set up your DFX in your system, my screen is visible, right? Yeah. So if you go on the DFX, you can go for Motoko Playground as well. Motoko Playground is another feature which we have installed, which not we, basically that ICP team has given us. That if you want to just go handy for your project as of now, if you want to just follow with the part which Anjali will be sharing, you can go for Motoko Playground as well. I would just show you that, let's say, the life cycle that we were talking about, which Anjali will be giving you brief as well. When you are deploying this project, the Hello World project, you are getting a canister ID here, which we were talking. This is the canister ID. Now you are the controller. You got the canister ID. You call these operations. You manage these. Let's say you write ETH Toronto. Perfect. And this ETH Toronto is the function that you are managing. Right now, if you want to manage this canister, you just perform certain operations on this. So this was the Motoko playground, which will be helping you understand more about the visualize the UI, the backend UI, which is the candid UI. But yeah, let's leave that as of now. Yeah, all over to you, Anjali.
Thank you, Chetan. And thank you so much for actually helping the users installing the DFX environment. I think that is one major step where you need to get started. So I've shared the important commands in the comment section also, and I will be pinning these important links at the end also. So I think what I would be doing right now would be creating a basic project with all of you so that we understand the life cycle a little bit in detail. So uh, I would be taking you step by step on each life cycle of the stage, and then we would be doing it. For that, let me just share my screen first. I hope my screen is visible. Chetan, is it visible? Mhm. Okay, perfect. So I hope we all have the DFX installed on our systems. you could follow the command which I have posted on the comment section for installing the DFX. And if you want to check whether DFX has been installed successfully on your systems or not, there is a simple command for it. You could write DFX _version. For example, it returned 0.20 for me. That means DFX is installed on my system. And if it would be for your system as well, then you would be returned by maybe a different version number, but definitely by something. So now that we know that DFX has been installed, also we would be needing the Node.js for this project. So please ensure that you have npm also installed on your systems. So as Chetan also pointed out, the first few steps would be the same. We would be creating a new project, a new ICP project. For creating a new ICP project, we are using the DFX commands. So what DFX actually is, it is a command line tool for us to create projects on the Internet Computer Protocol. So after we have installed this DFX, we would start by writing DFX new, because we want to create a new project. So let's just give a name to this project. Maybe we could do it as a demo project. Now, when I write DFX new demo project, it asks me for a backend language. So currently we are going to use Motoko, but as I told, we could also use other languages as well. But for this demo, we will be using Motoko language. So I'll press enter. Now it asks us to select a front-end framework. So in case you need a front-end framework, you could choose any of these options. It could be React, it could be Vanilla.js, it could be SwellKit. So for now, I'm going with the default one, SwellKit. So since we are not focusing on the front end in this demo, we just need one front end page, which would be self-created by selecting this. But our main focus would be on the back end, because back end is where the canisters are created. And there are some extra features which we could only press enter. And now it is creating a new project for me. We'll have to wait for a few seconds as it is creating all the dependent files and everything. The folder structure has been created right now. As you could see, the node dependencies are also being installed. I'll show you the whole project structure once we are done with the creation part. It could take a couple of seconds to get this done. Yes, and we are almost done. Wonderful. So as you could see, we can see the beautiful logo of Definity here, the ICP protocol here. And so the project has been created. So now it's time to move to a code editor. I use VS Code. You could use any code editor. So moving to the Visual Studio Code. And when I'll open my folder, so we could see demo project has been created. Let me open that. Yes. So first, let me explain the project folder structure a little bit. Okay. As you could see on the left-hand side, we have the node modules. The node modules are the node dependent files which are automatically installed on the system. Sorry for that. Yeah. Now there is a source folder created. If I expand this, so DFX has created two folders for me, the demo project backend and demo project frontend. And in the backend, there is a file known as main.mo. So it has created a default Motoko file for me. And this is a very default function. We would not be understanding the Motoko code today. So it's a way, probably in the upcoming workshops, we will be discussing about the Motoko language in detail. I'll be able to explain you the whole code. But for now, you just understand this is a simple, very simple hello world kind of function, which accepts an argument name as a text, and it will return the user with a message hello, followed by the name which you had given as an input. So very simple function for that matter. Now we have something called as the front end, where front end files are created. I will not go into the detail of the front end files. And here, one very important file which I would like to mention is the dfx.json. This is one very important file for us. Just a minute, please. Yeah. So dfx.json is a very important file because here this file actually tells us what are the canisters which we are going to create. So if you could see, it has created something called as canisters, and now it has kept the name as demo project backend. And the main of this is basically the address of the main file, and the type is Motoko. So what we have to do is, whenever we create new canisters, whenever we are going to create decentralized applications, we will be actually creating a lot of canisters. So the entries of the canisters have to have been mentioned here in dfx.json. It is a mandatory step. So this is automatically created for us right now. But if you want to add more code to it, want to create new canisters for it, please make sure that you make an entry here where you mention the name of the canister and the address of it and the type. It could be Motoko, it could be Rust, it could be anything. So the dfx.json file is very important in this manner. So we could see that there are two canisters for us, the backend one and the front end one, and the path and the type has been mentioned for them. Okay. So this was about the folder structure, and these are the config files. We need not worry about them. So now let's open the terminal. So in terminal, I go to new terminal. So what is going to be our first step? For anything to start, obviously, we want the DFX environment to set up. So one disclaimer here, today, whatever we are doing, we are deploying and creating the canisters on a local systems. So in case you want to create on the ICP mainnet, then you would need cycles for that. Cycles are the currency or the resources which are used to deploy or create canisters on the main ICP blockchain. And you could buy cycles by converting your ICP tokens into the cycles, or you could also claim your cycles through coupons. I think Chetan in the end would be explaining you the way of Definity, because it enables us, and the ICPHub Canada and US, we've got a few coupons. Whoever is interested in building applications on the mainnet of computer can ask us those coupons and redeem those coupons, and you would get some cycles for utilization. So Chetan would explain you all those steps later on. So for now, we could just understand that we are doing the whole thing on the local setup. So let me start the DFX by writing DFX start and _background. So what this background does is that in the background, basically, the DFX environment is being set up. So it would take a couple of seconds for this DFX to start. Once we'll be starting the DFX, then we would be able to maintain the whole life cycle of canisters. So as Chetan explained us, that the canister's life cycle begins by creating the canister. So for creating a canister, you should have a running DFX environment with you. So for doing that, we have used the command dfx start background. So if you are wondering why we're using this background, if you can only write dfx start also, but then you will have to open a new terminal and write all the other commands on that new terminal. So by writing this term background, basically the dfx service is running at the background. So we can finally continue writing our commands over here itself. So now, once we have started the DFX, it's time for us to do the very first step, which is the creation of the canisters. For that, we will use the command dfx dfx canister create --all. So a quick word. All the canister related commands are, you begin by writing dfx canister. You could see here. So there is something called as dfx help, dfx/help. You should always, as beginners, I think it's a wonderful step if you are stuck somewhere, or if you want to read the developer docs, I mean the command line help. So dfx/help is a perfect thing for you. once you type the DFX help, all the commands are displayed to you, which you could read in detail. So in case you stuck somewhere, so feel free to write DFX help and get some help, read about it. Also, one important thing, in case you want to highlight or you want to read more about a subcommand. For example, here I've just mentioned the command DFX canister. So you could also write DFX canister and then write -- help. This would elaborate you on all the subcommands, particularly in the canister, under the canister subcommand. So all the subcommands which you could use, for example, you could use DFX canister status. I'll be showing you this, or install, whether if you want to install the canister, the compiled code in a canister, or if you, for example, we used the word create here. We could also use call function to call a function once the canister has been deployed on the ICP blockchain. So for all, to get a basic understanding, I think this is a very useful command, DFX help and the subcommand. So for now, we have created the canisters. So let me show you once before the help. Yes. So this was the command which we wrote, DFX canister create all. Now this has helped us to create a backend canister as well as a front-end canister, and it has applied to us some canister IDs. Now these are the ICP generated canister IDs. So now I would like to point you to the folder structure. Go to your folder structure, everyone, and you would see that a new folder has been created, .dfx. If you expand the DFX folder, you would see that a new file has been created, which is canister_ids.json. If you click here, now you can see that the canister IDs which are displayed here have been created over here. So what does this mean? This means that the canisters which you wanted have been created with certain IDs, and these IDs are stored on this file. So every time you are utilizing the canisters or you want to update the code of the canisters, that is possible because the IDs are stored on this file. So the ICP knows, basically the protocol knows, the protocol knows which canisters are you specifying. You only need to specify the name of the canister and it automatically knows which canister ID you are pointing at. So that is the use of this network canister_ids.json. So now once we have created the canisters, now to give you some perspective, right now we have only created the canisters, which would mean that we have only created some empty containers which do not have any code in it because they are just outside containers with some IDs. But as we told that after the creation of the canisters, the code has to be installed on the canisters. So whatever code has been written here for the Hello World program, that has to be installed and then we have to deploy that on the protocol. So we can do that simply by writing DFX deploy. Now DFX deploy would actually build the whole code, the canister code. So it is showing building canisters, if you could see, building front end. So the canisters, the code is being built and the code is being installed and finally being deployed. All three steps at the same time by using the command DFX deploy. So now the canisters are being deployed on the blockchain. So for now, it is a local system. Otherwise, you could use a testing environment. You use the word playground for testing it on the development environment, or the mainnet. For mainnet, we use network IC. We'll be covering all of that in the upcoming workshops. For now, it's good if you could practice this on the local system itself. So yes, wonderful. If you could see, it is generating and installing everything for us. Once you see these green links, that means your canisters have been created, built, installed, and finally deployed on the protocol level itself. So now you could see, you could press command and you could click the link to go to the front end. So you could see that there is a front end canister which we can access via browser, and also there is a back end canister which we could access through candid interface. So Chetan here, I think showed you the demo of the Candid UI. I'll be also showing you this, but first let's move to the front end part. So let me click on this link. Here it is. So you could see that the local host with the canister ID, whatever has been created, has been created. Now this is your very first decentralized applications. You have created and deployed a canister for yourself. Let's go do some testing here. So let me write my name here. Wonderful. Yes, so it's working fine. So what it does is basically it's taking an argument, and once I click on the button, this argument is being shown by afterward hello. So it's being appended over here. That means it's working fine. So let me also show you the Candid UI for this. So for all the developers out there, it's you just actually sometimes you need to do the testing of the functions. So it's not required for you to create a front end all the time, because we are only concerned with whether our functions are working properly or not. So for that, this is an ICP created UI for us for checking the backend. It's a very nice interface wherein the function name is provided, the argument it accepts is told to us, and whatever it will return is also, the type of it is also mentioned, and query. So we will be discussing more about query and update calls in our upcoming workshops. For now, we just understand that there are two types of calls which we can make on this ICP protocol. It could be a query call, which would simply mean that we are reading the state of the blockchain at that time. We are not making any changes to it. But in case it is an update call, update would mean the right call. If you are trying to modify that, modify anything on the blockchain, then that would come under the category of a update call. But here, as we know that we are only reading the text and sending it over, and we're not doing any modification. So it's a query function. So if I just test here and query, so it is showing me this. So I think this is wonderful that this is running beautifully over here. Now moving back to Visual Studio Code. So we have seen till now that we created the canisters. We basically deployed the canisters, which involved all the steps of building it, installing it, and deploying it. And then you could also call a particular function of the canister. So in case you want to call a particular function, you could use the command DFX canister call. After that, you will have to mention the name of the canister with which you are referring. So in our case, it is demo project backend. Then we need to write the name of the function. For us, it is greet function. So I wrote DFX canister call, the canister name followed by the function. And I want to write Anjali. Here it is. The moment I press enter, it is returning me hello Anjali. So here also, in case you do not want to go to the Candid UI and you want to do the testing here itself, this is also one of the ways which you could do. So some other commands, as I was telling you when we saw the DFX canister help, so there were a few sub commands. One of them was status. So let me tell you. So just remember that whenever you want to check the status or whenever you want to do any canister related operations, you definitely need to mention the name of the canister which you are referring. Okay, don't forget that. So for us, it would be demo project, demo FX canister status, demo project. So little bit about this also. So if you see, it has returned me the status of this canister, that it is a running canister. So canister could assume a lot of states. It could be stopped, it could be started, it could be running. So right now it's a running canister for us. This is the controller, as Chetan was pointing out. So basically this is my address, principal address, because I have created this canister. So I am the controller for it. More information on controllers, I think you could go and explore that. Controllers are one important entity of the ICP protocol. They are the ones which control all the operations in the canisters. So if you could see the balance, as I told you, that cycles are the main resources on this. So since it's a local host, so these many are the cycles which have been created. Once whenever we create a canister, all the basic cycles are created. This is the basic cycles which are created. You could add more cycles to it, you could remove cycles from it, so that's another story. And all the other information is also displayed here. So the DFX canister status is one very important command for the developers, and you need to keep on checking this frequently. So this is it for it. And once you're done with all the applications, it's important to not keep your DFX running. So since now we have created the canisters, we have seen all the queries, we could also delete the canister if you want to, but then you need to stop the canister first and then do it. Or you want to just upgrade the canister for the next time, then you could just update it. So for now, I'm just stopping the canister by the DFX by writing DFX stop. And that's it. My DFX has been stopped, and we have successfully created our first application on the Internet Computer Protocol. So I hope you found this demo to be helpful. And yeah, I think we're ready for the queries now. Any questions on the demo or the theory part, please go ahead.
Thanks, Anjali. Thanks for covering up everything. I guess it was quite a, like, if I was a beginner, it would have been very easy for me also to just get started in building the application. And yeah, I guess we had great audience there. Hopefully everyone will be catching us up, and the project building would start now. And if someone has still any doubts, you can always ping us at our personal handles. Discord is open here, the ICP Hub ETH Toronto channel. And apart from that, ICP Hub Canada and US Discord is also there. So I guess you have complete access to all everyone, the whole team here. It's just that how much eager are you to build upon ICP? So yeah. Also, yeah, James, you can go ahead.
Thank you, Chetan and Anjali, so much. That was such a in detail demo and presentation and workshop. So I'm sure all our live audience will really appreciate that. Thank you to the live audience for tuning in. And if you've got any questions, make sure you drop them in the comments, or as Chetan said, find them on Discord. We want to support you with your building as much as we can. And if you're listening on catch up, then welcome to get involved. The links to the hackathon page with the details of the ICPHub bounties will be in the comments. And just a quick rundown of the timeline. So the online hackathon actually began on July the 13th. So registration is open now. If you're not involved yet, make sure you've registered and get building. The in-person event is at the Blockchain Futurist Conference in Toronto from the 13th to the 14th of August. So this hackathon is actually open to in-person and online, so anyone can get involved no matter where you are in the world. And the deadline for submissions is August 21st, so just under a month. Thanks again so much to the ICPHub team, Anjali and Chetan, for putting on this workshop today. Really appreciate it, and I'm sure the builders and hackers will get a lot from it to give them a head start.
Thank you. It was wonderful hosting here.
Yeah, again, yeah, we had like always it's amazing to get started with ICP and just teach from basics every time. And yeah, also before just ending up, we would like to share you about the Quantum Leap Labs, which is our incubator which is going on. So let's say I was talking about you are done with the hackathon, you are winning this hackathon, you got this bounty. What's next? So next step should be coming on to our incubator. If you're really interested after winning and taking this project forward, even if you're not winning, we are here to support you. You can just tap into Quantum Leap Labs ICP Hub Incubator. That is the place which will help your project scale, have you grant support, all the developer support. That is one place. Also, if you want to take a deep dive into Motoko, which is the native language of ICP as we discovered today, so there's ICP master program that is the first session is obviously on 29th, but anyways, will be you can be part of the sessions, all the consecutive sessions, which will be a hands-on session with around 8 to 9 session will be having around 8 to the complete series will be having around 8 to 9 sessions covering everything about ICP till the advanced projects. So you should definitely be packing up for that and get ready, and we'll be having everything hands on. So I guess Anjali, if you can share the link to that program, or I'll just share that.
We will pin the comments.
So
Pin
yeah, we'll
the
pin the comments, and
yeah.
everyone who was watching the recordings as well, just make sure all the links are captured from the live chat, the chat box. And yeah, thanks James, thanks for this wonderful session, and definitely all the projects, we are here to support you.
Yeah, can't wait to see what you'll be building. So let's get
Yeah,
going. Looking forward to it. Thanks, everyone.
thank you everyone. Bye bye.
Bye bye.
Bye.